Concept 4, evaluating polynomials. So evaluating polynomials is the same as when we factor them. We're just going to be asked to prove or show that our factored form and the original polynomial are equal. Okay? So to do that, we're going to plug in different values. Okay? And we're going to start with this polynomial, okay, this trinomial, and we're going to factor that. So we're going to start, we see that this is a positive c, right? My third term is positive, so I know that my second term should be the sum of the two factors. All right, so I can start by listing the factors. 1 and 30 obviously aren't going to work. 2 and 15 again aren't going to work. That's too large. 3 and 10, we're getting closer, but that 3 plus 10 would be 13, which is still too big. Let's see, do we have any others? Not 9, not 8, not 7, 6. So 5 and 6. Okay, and I think that should be it. And now we can see that these are all too large, and this is going to be our these are going to be our factors. So our binomial is going to be x plus 5 times x plus 6. Okay, so that's the two binomials that I came up with, and to see or to prove that it is equal to this trinomial, I'm going to create a table. Okay? And my table is going to have the original polynomial, my factored polynomial, and then the values that I'm going to plug in. Okay? So for x equals 0, I plug in 0 to all of my x's, okay, and I get 5 times 6, all right, which is equal to 30. And I get 0 squared plus 11 times 0 plus 30, which is equal to 30. So it works for 0. I get 1 squared, which is 1, plus 11 times 1, which is 1. So I've got 11 times 1, which is 11. So I've got 1 plus 11, which is 12, plus 30, which is 42. And over here I've got 1 plus 5, which is 6, times 1 plus 6, which is 7. 6 times 7 is 42. And now up to 2. 2 squared would be 4. 11 times 2 is 22. 4 plus 22 is 26. Plus 30 is 56. 2 plus 5 is 7. Times 2 plus 8, or 2 plus 6, which is 8. 7 times 8 equals 56. And that's it. Okay? I've proven that at least for these three values, my factored polynomial has the same result as the original. Okay? And that's all I need to do. There are 1 or 2 questions like this where you have to make the table. Otherwise, you're still going to be doing the factoring, and you can choose a value to check your work to make sure it works. And that's usually a smart thing to do. I would recommend checking your work to make sure you didn't make a simple mistake. But the table is only something you have to do for those questions that ask you to prove or show that these are equal for a certain number of values.